What's up, guys? We're going to be talking about density today. I hope you guys took an opportunity to watch the other two videos, so you guys should have a rough idea of what density is. Density is a ratio between mass of some substance and the volume it occupies. Okay, so density is mass divided by volume. So that's our general formula. Density is equal to mass over volume. Okay, typically mass we're going to measure in grams. And volume, we have two options. It could be in centimeters cubed, so cubic centimeters, or milliliters. And it's important to note that 1 centimeter cubed is equal to 1 milliliter. Okay. If you're wondering why we're not using ounces and inches and feet, it's because our units of measurement here in the United States are dumb. We should be using a metric system like everybody else in the world, but I digress. Okay. So again, if you think about what a cubic centimeter is, it should be something like that, right? 1 centimeter by 1 centimeter by 1 centimeter. Okay. And if you find something that's liquid, you can get an idea of what a milliliter is. Okay, so 1 milliliter is one. These are, if you guys remember in class, those little orange blocks you use, the ones, tens, hundreds, and thousands. That's what these are. So when we're looking at things on like a very small level, right? Say this was 1 cubic centimeter, right? And we look at this and they have the same green balls in both of them, right? So we'll say this one has 1, 2, 3, 4, 5, 6, 7, 8. It has 8. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. Now they both occupy the same volume, right? They do. They both have the same cube that they fit inside. So the ratio here is 8 to 1. The ratio here is 22 to 1. This one is much more dense, and this one is much less dense. Okay. So if we think about this, one of the ways that we can kind of express this is whether things will sink and float, right? The more dense things are, they sink to the bottom. The less dense things they are, they kind of float up to the top. Okay, so there's all sorts of different stuff here. You can pause the video and take a look if you want. But water right here, water which has got some green food coloring in it, is kind of our standard bearer that we use. The density of water is 1 gram per milliliter, or 1 gram per cubic centimeter. Okay. So water is kind of our benchmark. Okay, so anything with a density less than 1 will float in water. Anything with a density greater than 1 will sink in water. So all of these things, the dish soap, the milk, the cherry tomato, the maple syrup, the corn syrup, the honey, and this bolt down here, this popcorn kernel, they'll all sink, right, below the water, right? And everything up here has a density of less than 1. So vegetable oil, rubbing alcohol, lamp oil, this ping pong ball, right? All these things have a density of less than 1, so they float above the water. But also, if we want to say something, we can say that maple syrup, whatever, I don't know what the density of maple syrup is more dense than milk, right? Because it's below the milk. Okay, so if you want, you can, if you've got a glass in your house, a very skinny glass in your house, and you want to try this out, you can do it. Just pour it in very, very slowly. Otherwise, it kind of becomes a mess. If you do pour it in and things haven't mixed together, just let it sit on your counter for a while. Eventually, it will separate. Okay, but this is also outside of water. This is also why something like a hot air balloon, right? So in a hot air balloon, what you do is you heat up the air and it occupies this space, right? So you're doing two things, right? You're definitely increasing the volume, right? This is blowing up. It's getting bigger and bigger and bigger. But also what you're doing is you're making the air inside of that less dense. Hot air is less dense than cold air. This is why they always say hot air rises, right? This is why if there's a fire in your house, they always say to get close to the ground, right? Because the hot air rises, it pulls the smoke up with it, and there's less smoke next to the ground. Okay, so hot air will rise compared to cold air. Okay. Helium is a little bit different, right? You think about helium as what we fill up balloons with, right? So where am I periodic table go? So helium is right here. Now most of the air around you is made out of nitrogen and oxygen. Okay, so this is a majority. So if you notice that these two are heavier, 14 and 16, and helium is only 4 down here, right? So if they occupy the same amount of space, helium is not only lighter, but also kind of like we looked at here, it's going to be less dense, which means that helium will float in air. That's why if you fill up balloons with helium, they will float. If you notice, there's other things that will float, like hydrogen. Unfortunately, the other thing about hydrogen is that it is super highly flammable. So if you fill up a balloon with it, and they used to fill up blimps with it, if you had a little spark, it would cause a huge fire, and not good for business. Okay, so odd characteristics, something like water, like you would think ice would be more dense, but we know that ice also floats. So water has this very weird property that when it becomes a solid, right, when you freeze it, it becomes a solid, it actually becomes less dense. And that has to do with the molecules. When they become kind of this crystal shape, they actually kind of align themselves in a way that they increase the volume, right? So if you guys have ever accidentally left a can of soda in the freezer for too long, it'll burst, right? Because what happens is you increase the volume. It'll expand and increase. This is why, like, when you twist your ice cube trays, they kind of crack out, right? Because they've expanded inside the ice cube tray, and you kind of have to break them loose. But it's worth noting that cold water is still more dense than warm water. So cold water sinks, but then as soon as it freezes, it'll pop up to the top of the water. So here are your 3 formulas. Density is equal to mass over volume. Mass is equal to density times volume, or volume is equal to mass over density. So if we just start off with the main one, right? Density is equal to mass over volume, right? Well, we know if I multiply both sides by volume, right? I multiply this side by volume, this side by volume. What am I going to get? Mass is equal to density times volume, right? And the other thing you guys should know, if you want to take this a step further, if I want to divide both sides by density, I can also say volume is equal to mass divided by density. Okay, so these are your 3 different formulas. You guys should know how to manipulate these formulas at this point. I do want to just show you guys something that's a kind of a cool trick, though. If I said that 4 was equal to 8 over 2, the cool thing is whenever you have a number on this side and the number on the denominator here, you can switch them and the statement is true. So if I switch this 2 and this 4, 2 is equal to 8 over 4. Still true, yes? Okay, so just a cool thing you can remember here is if you switch these two, it still works, okay? So the cool thing is if you have 2 out of these 3 things, you can solve for the other one. And a very important idea for us is that most objects have what's called a specific density. We know what the density of something like gold is. We know what this density of lead is, right? They have specific densities. We know what the density of ice is compared to regular water, compared to cold water, compared to oil. All these things have a specific density that we know. So if you know the density of them and they're given a volume, you can tell how much it weighs. Or if you're given the density, right, and you know the mass, then you can find the volume. Okay, so we can use specific density very much to our advantage. Okay, so the student measures a mass of an 8 cubic centimeter block of brown sugar to be 12.9 grams. What's the density of the brown sugar? Well, again, what do we got? We got density is equal to mass over volume. Okay, so we're trying to find the density. We know the mass is 12.9 grams. We know the volume is 8 centimeters cubed. So you break out your calculator. Right. You say, hey, what's 12.9 divided by 8. We're going to get 1.6125. The density is equal to 1.6125 grams per centimeter cubed. Okay, so your units are actually a combination. It's going to be two different units. So it is worth noting that you need to have both of those there. That is appropriate. But also, just by looking at this, you should know if the numerator is bigger than the denominator, that this number will be greater than 1. Okay, with that, and again, 1 being water at room temperature, it's good for us to know, right? That means that this will sink, right? And if you think about this, if you've ever put sugar in water, it will sink to the bottom and you have to stir it up, right? So a chef fills a 50 milliliter container with 43.5 grams of cooking oil. What's the density of the oil? So density is mass over volume. So your density is equal to 43.5 grams over 50 milliliters. Okay, and again, what do we know here? We know actually the denominator is bigger here, right? So we know that this number is going to be less than 1, which means it will float, right? And if you guys have ever put oil in water, you know the oil floats up to the top. So you break your calculator, 43.5 divided by 50, you're going to find out that's 0.87. 0.87 grams per milliliter. Okay. Here, they want you to calculate the mass of a liquid. Okay, so if you want to find mass, oops, wrong way. Mass is density times volume. Okay, so mass is equal to density times volume. Okay, so again, what are we going to do? Mass, liquid with a density of 2.5 grams per milliliter times your volume, which is 15 milliliters. Okay, notice that this is milliliters on the top of a fraction. You have milliliters on the bottom of a fraction here. They cancel out. Okay, and 2 times 15 is going to be 37.5. Break out a calculator for that if you need to, and grams, right? Again, the milliliters cancel out. You have milliliters on the top, milliliters on the bottom. All that's left is grams. Okay, it says calculate the volume of a liquid with the density. Okay, so what's our formula for volume? Volume is mass divided by density. Okay, so again, what do we got? Volume is equal to mass, 65 grams, over the density, which is 5.45 grams per milliliter. Okay. If just again, think about this, if you thought about just the units, right? This is grams divided by grams per milliliter, right? Grams divided by grams per milliliter. You keep, you change, you flip, right? So all you can be left with is milliliters as far as the units go. Okay, and 65 divided by 5.45, 65 divided by 5.45 is going to give us 11.93, we'll call it. 11.93. So again, knowing the density of an object and the mass of it, or some substance, right, we can very easily find the volume. Okay, so I'll do one more just to show you guys. A machine shop worker works with a mass of an aluminum cube as 176 grams. If one side of the cube measures 4 centimeters, what's the density of the aluminum? Again, density is equal to mass over volume. Well, again, we know the mass, right? Density is equal to mass. Okay, and the volume, they told you it's a cube, and the side measures 4 centimeters. So that's a cube, right? All the same dimensions. 4 centimeters times 4 centimeters times 4 centimeters, right? 4 times 4 times 4, right? Length times width times height. 4 times 4 is 16. 16 times 4 is going to be 64. Okay, so yeah, you are going to have to do a little bit of calculations. Okay, And again, what do we got? 176 divided by 64, 176 divided by 64 is going to be 2.75. 2.75 grams per centimeter cube, which makes sense because we would expect a cube of aluminum to sink in water, right? So obviously this is much more dense than water, okay? So anyway, you guys give something to try, and let me know if you have any questions. Thanks.